Okay, so we were talking about in the last time about how you can calculate the either hydronium ion concentration or the hydroxide ion concentration using the equilibrium constant for water, which at 25 degrees is 1 times 10 to the minus 14th. Now we're going to look at to see if that produces an acidic solution, a basic solution, or a neutral solution. So a neutral solution is when the hydronium ion is equal to the hydroxide ion, and that happens when either one is exactly 1 times 10 to the minus 7th molar. And that could be either hydronium ion concentration or hydroxide ion concentration. This is obtained basically by taking the square root of 1 times 10 to the minus 14. An acidic solution is when the hydronium concentration is greater than the hydroxide ion concentration, or hydronium is greater than 1 times 10 to the minus 7th. And also means that the hydroxide ion concentration is less than 1 times 10 to the minus 7th. And of course, these are dealing with minuses. So if I have a minus 9, that's actually smaller than minus 7. So keep that in mind. A basic solution is when the hydronium ion concentration is less than the hydroxide, or hydronium is less than 1 times 10 to the minus 7th. And of course, I can also say that by saying that the hydroxide ion concentration is greater than 1 times 10 to the minus 7th. So if we look at this problem on the next slide, it wants to know if the following solutions are acidic, basic, or neutral. So it's 2.0 times 10 to the minus 11th molar hydroxide. So this is less than 7, and so it's less than 7 and hydroxide. So that means, so if it's less than 7, it's going to be the opposite to what is here. So this would be basic, but being less than 7, it's the opposite, so it's actually acidic. If I look at this one, I have minus 9. It's 5 times 10 to the minus 9th. So again, this is less than 7. So it's going to be the opposite of what is written here. So this is basic. I look here, and this one is minus 3. So this is greater than minus 7. So if it's greater than minus 7, then it's going to be whatever this is indicated here. So this one is also basic. And minus 6, 2 times 10 to the minus 6, only if this is minus 7 do I need to really look at this number over here. So minus 6 is also greater than minus 7. So it's the same as what is written here, so that is also acidic. And that's basically how you look at those. This is showing, the next thing we're going to be looking at is the pH of a solution. pH is the negative log of the hydronium ion concentration. So it's a lowercase p with a large case H, and it's a negative log of H3O plus concentration. Now, there's a couple things about this. First of all is that it could also be pH. If most times in biology you will see it as being the negative log of H plus concentration. And it's exactly this. These two are equivalent of each other. But in reality, this P, change colors here. This P is a mathematical symbol. P. P means negative log of something, of let's say X. So this formula is given to you on the formula sheet. There's going to be another formula that's not given to you, which we're going to start doing with the next slide, which is P. So basically Px is the negative log of the concentration of X, and this means the brackets simply are a denotion of concentration. So what we're getting to is that POH will be the negative log of the OH minus concentration. And so this formula is not given to you on the formula sheet for the test. Okay. This is showing the pH scale is on the bottom. And I've kind of started the chapter out with this. If you notice, you have lemon juice, carbonated water, beer, vinegar. Coffee's not on here, but coffee is also acidic. And then you transfer over to the basic area, baking soda, milk and magnesia. So this is an antacid. These are cleaning supplies, and these are basic. Neutral is a very, very specific. Neutral only occurs right here on, right here on this line. If I could draw the line straight, it would be great. But basically only at a pH of 7 or 1 times 10 to the minus 7th. That's the only place that neutral actually appears. So this is looking at the following pHs and if they are acidic, basic, or neutral. So all of these are given our pHs. So pH of 12.9 is basic. So what you have is if the pH is less than 7, it is acidic. If the pH is greater than 7, it's basic. And only when pH exactly equals 7, then it's neutral. So when a pH is 8.9, this is greater, so this is also basic. 5.1 is less than 7, so that's acidic. And 1.6 is also less than 7, so that's also acidic. And that will be the end of this video.